And we're here. All right, let's go ahead and get started. So I prepared a quick demo of continuous delivery using TeamCity and Octopus Deploy. And although I'll talk about it as with Azure VMs and whatnot, this can be replicated in any cloud environment, any VMware, anywhere where you have really flexible virtual infrastructure, because the cloud enables us to add another environment really easy and make 4 steps versus 3 in the continuous delivery pipeline. But we're not going to get any Azure specific stuff. I'm really going to talk about how the source code is structured, how the TeamCity builds are configured together, the scripts that are part of the source code that integrate with TeamCity, and then TeamCity's integration with Octopus Deploy, and then the process of the scripts and how Octopus executes it on each of the progressive environments. And in this case, you can see we have a 3-stage deployment pipeline. We have the integration build, which is the continuous integration build, and then we have deploy to test, and then promote to staging, promote to production. So that's just, and you can have as many stages as you need to. You can chain them together. And on the Octopus Deploy side,
and that kind of answers your question of what we're doing all the way to production. Mm-hmm. Yeah.
So in this case, we have a project, and it's called Clear Measure Bootcamp. This is a sample application. I'll show you the code in a little bit. But if we go to our Environments tab, and this is the Octopus Deploy dashboard. I'm not going to go over how to download the product and install it, because it really is just a next finish type of scenario. And it's a very affordable product, and it's free to test. Like this right here is with the trial license. So just to get your stuff going, to prove out that it's possible, you don't have to buy a license. But once you get into it, then it's still really affordable. And compared to the time savings, I mean, it's hands down super cheap. So this is the environment view, and you can see the test environment is configured with, and I'll make this a little bit bigger. The test environment is configured with a web server on the right, a single web server, a database server, and then there's a test server. And that'll be important as we go through. And then the staging server is configured with 2 web servers. You can see the gray tag is the role as we label what type of server is this. And those names are really so that we can tie a particular component of the application to a role. For instance, if there's certain components of the application that need to be deployed to the web server, this is the way we tell Octopus deploy. This is the web server. And so it'll deploy to both of them, the database server and test server. Same thing in production, we have 2 web servers. Okay, so let me start with a description of the environment. I'll walk backwards back into the code. All right. So with Octopus Deploy, we start out and we create a project. And the project on the left-hand side are the things that we can configure. And you can see for this particular project, we have a couple releases that are present. However, if we click on releases on the left-hand side, we have a full record of all of the releases that we've done recently. It starts to pare it down, but 1.1.38 is the most recent release.
Are those releases created by TeamCity?
Yes, they are. Yeah, the version number is created by TeamCity, and then it flows through every step of the process, and it tags back into GitHub upon successful build. All right, so if we go to just the release, you can see we have a 3-stage cycle: test, staging, production. And the packages are, we have a database package in our application, a UI package, and then we have tests. The purpose of continuous delivery is so that we can, in a completely automated fashion, run every step of validation and testing without a whole lot of manual tasks, and ultimately get to production, if you want to, without any human intervention. Now, the extreme of continuous delivery is called continuous deployment, and that is things go all the way to production without any human touch. Continuous delivery pulls back from that just a bit and says there will be some manual approval processes somewhere in there. And so continuous deployment is the completely automatic. And that's what Netflix and Spotify, that's what they do, where somebody puts it in the code base. If it passes all the tests at every stage along the way, it's getting to production. And that's the extreme, and that's called continuous deployment. For most people, whether it be the business stakeholders, the client, or somebody, is probably going to want to at least look at it and at least give the thumbs up. So in most cases, the continuous delivery is a good compromise, where you at least have a approve button, and if the approve button is pressed, well, everything else is automated, so that you just at least have that check where you can say, okay, it's passed everything, it's ready to go. If we press that button, it's going into production right now. And of course, it's automated to go in there, no manual steps whatsoever. I'm going to run this all the way through, just so that you guys can see it, and then we'll come back and we'll go into every step of the way. So I'm not going to make a code change, but I'm going to run the integration build. Now, if I refresh here, now this is, you can see the URL right there. It's the test web 01 up in the top left. Now at the bottom, we have on the page the actual build number embedded into the application as deployed. Now, in production, you probably hide some of this, but you can see release 1.1.138 at the bottom, and you can see that there's some. This is the machine and the database name that it's going against. Okay, so I just had it spit it out, because on deploys, we'll see we can push some things in via replaceable tokens, and so this is an example. And if we go to the staging environment, hit refresh, we see we're on version 138, and production refresh, I had just pushed it to 138 right before here, just to make sure my demos work. So let's go through, and I'm just going to force this build here. I'm going to just hit run in TeamCity. We're forcing the build, but if I was revving and make some code changes, then it would see up on GitHub, oh, the code changed, and of course it would kick off just like any continuous integration server does. But I'm just going to force the build. And so it is, it's going through its thing. I'm going to click on this particular build and go over to the build log, and it's running through a build script. There are, we're going to build local database. We're going to do a whole bunch of compilation. We're going to run unit tests and integrations together on this really small application. Is about 84 of them. While this is running, I'm going to show you where the source is on GitHub, and you can pull it down. It's open source. It's on our github.com/ClearMeasure Labs organization, and the repository is ClearMeasure Bootcamp. And you can pull it down, and you can see the build script, which uses Saki syntax, and so you can see all the parameters here, but the CI test, these are the steps that it goes through. So if you're used to using Nant or something else, then it's going to initialize some variables. It's going to stamp the DLL. It's going to generate. Yeah, we'll pause. Hello, come on in. Welcome to AzureAustin. We're just in the middle of a continuous delivery demonstration. So in this step of the build, we are actually generating an assemblyinfo.cs file. And because we're generating it, we have the opportunity to push stuff into it, like the version number. And when you compile with MS Build, it uses the version number that's in an assembly level attribute. Are everybody familiar with that one, or should I show it? Let me show it real quick. Sure. Okay. And Let me just.
I've been using this Team City functionality to change that version number, but I'm curious.
Yep. So this way, the version number actually gets stamped inside the DLLs when they're compiled. So you're familiar with assembly info, and if we did nothing, then all of our DLLs on disk would actually be stamped with 1.0.0. And because we're regenerating this file on the build, it actually is stamped with the actual version number. So when if you were to email me that DLL file and you looked at the properties and looked at the version, it would be the right version for the one you built. So after it's deployed, if anybody's ever looking at this server and it was deployed using this whole process, and they looked at the actual binaries that were on the server, it'd be no question, because every single DLL is stamped with the same version. So we have meticulous record keeping all along the way. And then we do a few things, compile, test. Now, I'm going to jump back to Team City because I think that we've already probably moved on to the next step. I'm going to hit on build chains because these builds are chained together. And we see that the integration build passed. And when the continuous integration build passed, so is everyone using continuous integration already and probably stopping right there? So continuous integration build passed, we automatically kick off another build configuration, which is deploy to test. And it just passed. Now if I go over to, no wait.
Is that a distinction between continuous integration and continuous delivery? It's a failover to another environment?
No, continuous
Just talking about
continuous deployment is no manual intervention at all ever. Continuous delivery is what we're doing here because we do have a manual step.
So
Let me.
integration versus
Oh, I'm sorry. Continuous integration is the build process, build and test, no more than 10 minutes for the team, but does no deployment. Does no deployment to anything. So let me get through here because this is automatic. This is version 1.1.139. So if I go over to Octopus Deploy, go into our dashboard, we can see that production is still at 138. Test has already been deployed to 139, and staging is in the process of getting deployed to 139. So if we kind of take a sneak peek in what it's doing with staging and look at the task log, then we can see if we say expand interesting, we can watch it because it's log every step of the way. So we're on the UI step, and it's doing a whole bunch of stuff. It's configuring the IIS settings and doing its things. So you can watch it and every step of the way. We're finished with CM Staging Web 01. We're going on to CM Staging Web 02, and it's just doing its thing. And while it's doing it, if I come over and peek at our test server, remember CM Test 01, see how it's version 138? If I refresh, it's 139 because we've already deployed it. Okay? So if I go back here, scroll down, you see there's tests. Let's see. I changed something here. Never mind this. Never mind the man behind the curtain. I was fiddling with the demo, so not doing exactly what I intended to do. But if I refresh, it should finish staging. When we come check Team City, because Team City is linked, and you can see that it's waiting. Team City is waiting on Octopus Deploy. Okay. So while this is going in, I'm actually going to go into the build configuration of the integration build. I'm just going to show the high points. So I'm going to edit the configuration settings for this. And version control settings is, hey, pay attention to GitHub. That's pretty much it. Triggers is, when should I trigger a build? Well, regular continuous integration. Hey, trigger on check-in, right? Everyone's used to that. What build features have we added? Well, we've added in-unit processing. Can I make it bigger? Yeah, in-unit processing. Check for free disk space. By the way, when you set up continuous delivery, you need these build and test servers. You need a lot of disk space because you have lots of versions being thrown around, and you want to keep around all these artifacts, and you don't. So you need lots of disk space. Just running this demo with a sample application on my box, I mean, I'm routinely like just running it through a couple times. I'm using up 3 gigs, and then deleting some old stuff. So you need realistically several hundred gigabytes on a server that's going to hit it, just free space and use it, and it's going to make.
Is that some sort of a script that you have, like the free
that cleans it up.
space?
Well,
I'm just curious as to what.
oh, this is built in. Free disk space is a built-in Team City server where it'll go back and it'll delete artifacts from older builds just so that the server doesn't end up with no disk space. So it'll automatically, if you put this in there, it'll automatically clean and delete stuff that you specify as older than whatever is, is not useful anymore. Okay, there you go. It's just built into the product. Performance monitor is it'll collect a whole bunch of stuff on the build server just so you can have some pretty charts. And then VCS labeling is so that when you go back to GitHub, it'll have labels on this. Parameters, let's see. Environment variables are our friend. So in the PowerShell build script or any command that's running whatsoever, it's one thing to be able to pass in a parameter via the command line into a script. It's so much more convenient for the build server to just say, you know what, I'm going to stick these in environment variables. And that way in the script, wherever, I don't have to chain them everywhere. I can just say, hey, with the process I'm running, do I have this environment variable? If I do, great, use it. And it uses it, it puts it as scoped to the process, not the machine. So the build number is available, and the configuration is release. And then for artifacts, if we go back to the general settings, the artifacts are the new packages. Now, Octopus wraps up the different components of the application with NuGet packages. NuGet packages in Octopus deploy the unit of deployment. So in our case, we have our and this is a good time to go to Visual Studio to just quickly show. I have to move this. Quickly show our projects. So right on the right-hand side, we have a UI project, which is ASP.NET MVC 5.2. We have integration tests, and we have a database project for automated database migrations. It uses the tool AliSQL, and it can upgrade a database using SQL scripts in source control, so that when you add that column to your database, it can be automated all the way through production. And you know that the script that was run to alter table, add column, you know that that's been tested multiple times before you actually run that SQL script on production. And so that way, even if you make some database changes, it's 100% automated for every environment. So those are the three that we're creating NuGet packages. And so it's easy to say, oh, the UI, that's probably the most obvious one. We need a website to be deployed. And so we see that we have UI/bin/UI dot build number, build number parenthesis, new pack. So we have an artifact that's going to be UI.1.1.139 dot new package. And so let's go back to the build.
Is this what we call NuGetizing?
Yeah. So these artifacts, if I scroll down, look, this is the actual package. Now, if I were to click on it, it downloads for me. And NuGet is just a glorified zip file. So if I open this up and I just say...
So does Team City know what to do if you specify, spit it out to a new package
zip? Team City doesn't care, doesn't actually know the format.
Okay.
It's just a file.
Okay.
It's just a file. So I renamed it to zip, and I just opened it up. And if I go to bin and go to clearmeasure.ui, and if I go, I might have to unzip this to look at, yeah, I need to unzip it. So if I copy this and go to my C drive and just paste it in here, continue. And then I right click on it and go to properties, and I go to details. Do you see the version number? There we go.
Yeah.
So the DLL is stamped with 139 inside a NuGet package for the website component of our system. And the NuGet package has a version number, and it's all the same, flow through. So regardless of what step we're in, whether we're in test or staging or whatnot, everything has meticulous records, and you never get confused about what version am I working on. And it's because when there's a bug, if we go to if we go to staging and someone is, in this case, staging is the one right before production, and they're going around and they find a bug, well, they can just look at the bottom of the page and see the release number, and then when they file the bug, it's crystal clear. And so now we can go to we can redeploy, if this is an older one, onto a test site, and we know it's the same version to reproduce the bug. All right, so let's keep going. Let's go back to this particular one. We can see in the continuous integration build for this one, we can see all the tests that ran. We can look at the duration of some of the slow ones as a chart, as a line graph, to see how long it took and are they getting slower or whatnot. We have perfmon built into here for what is from a CPU perspective. There's Tom. From a CPU perspective, or disk and memory, and then our artifacts, of course, and we can see everything inside of it. And of course, our integration tests, we have the in-unit runner, we have some of those DLLs so that we can run tests. So if we go back to build chains and look at this last one, catching up here, we see that deploy to test worked, promote to staging worked, and promote to production was success. Now, we see that 64 tests passed against our test environment, 64 acceptance tests, and typically in a test environment, you want full system tests to run against it. In a continuous integration environment, you want to run your unit tests, and they should be blazing fast because they're not even calling out a process. They're just calling a method or a class, and they're quick. Integration tests, maybe calling out to a database, testing an individual query, they're a little bit slower, but they're still pretty fast. You can get a whole heck of a lot of them. You can get 5,000 of all these tests running in a 10-minute build. Okay, so that's continuous integration. But pulling up a web browser, navigating to several pages in succession, going through a full user scenario through the application, those are pretty slow. And so those tests you want to run against after the continuous integration build in the test environment. And then if all those tests pass, then we promote to staging. We've got 3 smoke tests configured here that just make sure the deploy was successful and that the environment will change from a downsized test environment like that was not in a web farm with only 1 web server. Now we're going to staging, which has 2 web servers working against 1 database. And okay, we have a different configuration that is like production. So what kind of smoke tests are appropriate here that might tease out if we're going to encounter any problems when we promote to production, and then we go to production. So if we go back to Octopus deploy, you see that the staging build was completed successfully, but not production. Now, when I go to staging, if I go to the web smoke test step 5, and I open up, let's just open up the first one, you can see the build output that these are the web pages that were called. And this is just a smoke test built into the deployment step. And really all it uses is a PowerShell script, which I'll show you later, that actually loads up Internet Explorer right here, headless, without showing anything, and actually calls the URLs, and it causes IIS to be spun up, it causes the configuration to be read, it causes, whatever database queries happen when you happen to navigate to, when you happen to log in and just click around this. This is a expense report, a very small, just expense report application. And you know what? If we know that if we can just click around the application and go to these pages, it was a successful deployment. Otherwise, something would be blowing up, right? Fair enough. Okay, so let me go back to the releases, 139. Production says this task is waiting for manual intervention. So I'm going to click on manual intervention, and whether it's if you want your business stakeholder coming into this system, then they can say, oh, assign to me, and they can say, put something, but most of the time they're just going to give a thumbs up, send an email, whatever, and then you can say, Bob Barker approved prod deploy on 1/20/2016 at 6:30 p.m. And whatever you want to put, you hit proceed. That's it. and then you just sort of watch it do the exact same process that it did in test, the exact same process as it did in staging. Well, it's not the exact same process that it did in test versus staging because of the difference of 1 versus 2 web servers. But that's taken care of as we let this go. That's taken care of in the environment, which I'll come back to, and I'll edit the test environment. Actually, not that. I will edit this particular server. And so this says display name, but it really is the address. So this is the spot to actually put the server, and it needs to be a DNS address. So if everything's local to your network, then maybe you only need the name of the server if it's right there on your local network. But that's the name and address of the server. And you say that, okay, this particular server, CM Team City Agent, well, that's the one that our test suites run from against the test server against it. So
Is this a tentacle right here?
all of these are tentacles. Every server has to have the tentacle installed. It's just a little thing. Let me go to the website. That's actually better. So here, there's the server, and this server only has a role in the test environment. You can see right here, and the role of it is web server. Now, if we did this and we hit save, next time we did a deploy, Octopus Deploy would actually deploy the database components onto the server. Well, it would fail because it's not meant to do that. But that's how you tag that this server should have the database deploy process run on it. Make sense? Okay. And it's a listening tentacle. You got a thumbprint, and the tentacle URL has a port. You can change the port, but it's pretty much standard. Okay.
So okay, let's say I just deploy a web server to one tentacle and a database server to another. How do they find each other?
Good question. So this database server right here, this is configured. Okay, actually, I will go back to the deploy script. So how do they find each other? In the process, let's just walk through it. Let's do, okay, production happened. I'm just going to go through the log. Our process is to deploy our database, then deploy our UI, then execute our tests, and then do some web smoke tests. So the UI step is your question is, I need to deploy my website, and the website needs to be configured with the connection string to that particular database for that environment, because each environment has a different database, right? Whether or not you put the databases on a shared database server, or whether or not you have completely different databases, whatnot, in pre-production environments is your business. You can do whatever you want. So let's go through the UI and what the steps are, and the log will have us walk through. So a lot of this is going to be checking for stuff in standard Octopus deploy, but actually the better way to go through is through the process. That's going to give a better view. So this is the configuration of the process, and we're going to edit the process. And so this step, it's called UI. It runs on any server that is labeled with a role of web-server. And window size is, okay, if you have 17 web servers, how many web servers should it attempt to be installing at the same time in parallel? And you can put whatever number you want. The NuGet feed for how do I get the NuGet packages is Team City has a built-in NuGet feed with the artifacts, and so that's just the connection. That's a standard one. And so as I come down here and look at these two, we have configuration variables and configuration transforms. I'm going to come back to those, but I'm going to look at the bottom. There's a lot of stuff here. At the bottom, I'm going to hit configure features. These features, whichever ones you check, are the ones that are going to be added. Now, configure variables is going to take any file that is .config and is going to replace any tokenized names that you had placed in the config file with variables that are found in Octopus Deploy. And I'll show you where the variables are.
Configure variables is a configure feature. Is that correct?
Configuration variables is a feature. You can check the box, and then it'll do it. So we're doing that as well as substitute variables in files. It doesn't matter what kind of file it is. It means that if you have hashtag open curly brace and then the name of the variable in any file that is specified, then it's going to be replaced. Okay, I'll show an example of that. And then because this is a UI, it has built-in IIS website and application pool configuration that we have. So if I now all this is IIS, and so we'll just kind of cruise past the IIS and go back up to XML. Now, I'm not, in this particular example, I'm not actually using web.release.config, but it does get transformed. What I am going to show you is an example of, probably the best example, substitute variables in files. Because this one is, it doesn't matter what kind of file it is, you give it the path to it, and this is actually 2 lines, so it's 2 files. And it's going to look in there, and it's going to see if you have any Octopus deploy tokens, it's going to be pushed in. So if you click on this little guy right here, you can get a hint of what are all the different variables available to you. I mean, you have access to everything, right? Anything that you could want under the sun. Like, what server am I on right now? So UI is run in test and staging in production. It's run on 2 web servers and staging in production. So we have 5 different web servers across our whole environment. And regardless of what server it happens to be running on now, I could do octopus.machine.name, boom, and I know what machine I'm on. So if I go to view/shared/layout, and I'll just do it right here, _layout. That's it, and the MVC layout here at the bottom in my footer, you can see that I've got some of these. Here's octopus.environment.name, which is test or staging or production. So this is my master page or my MVC layout, and it's at the bottom. So that's how I showed you the web page, and the machine name and the version number was at the bottom, right? Because on deploy, it's the exact same version, same set of files, but on deploy, that information is being poked into it as the files are being copied onto the drive of that particular server. So, and really, it's up to you. Whatever variables you would like put into here, just tokenize it and whatnot. I mean, you could even add stuff. If you want to get creative, you could create a variable and use your imagination, because I don't have an example of that, but you could go up here. I'll show you the variables that I'm using. We have database name, database server, site bindings, and you can see you have site bindings as multiple times because the value is different based on the server name being different. Make sense? So we need a different variable. We need a different value based on the server that we're on. So this is how you can, if you have relationships like that. But if you created a variable that was show diagnostic information, and I'm going to give you an example. Show diags, and then the value was true, or actually, if you do in Visual Studio, if I do this, then it's a comment in HTML and it's not going to show, right? So if you think about it, you could do show diags begin, and we could have this configured for the test for production environment, and we could do the end, and essentially you could tokenize that in there, and in production you'd have the same stuff, but it would be behind an HTML comment so that it wouldn't be visible on the screen, or you can use CSS. So I mean, if you think about it, you can do what you need to just by poking in something small, even if it's poking in a little bit of HTML in a particular file to hide a section of something if we're actually going to production, but still leave it in the page so that it's, commented out or something like that. So that was just an example. And there's any number of ways. I mean, you could do CSS display none, or you could just have it not be outputted whatsoever. So that's an example. All right. So let's go back and show how to actually hook all these together, because setting up Octopus Deploy is pretty straightforward, but getting all these together has some specific steps. So if I go to deploy to test, I'm going to edit the configuration settings so that we can see what we've changed. Version control settings, there's none. This doesn't go to GitHub. This does not get code, because we're not going to compile anything here. We're going to take the release that already has been built and packaged up for us. And so in the general settings, if we see the build number format, you can see that I'm not setting a build number. I have a dependency on the integration build, and I need to use the build number from the integration build. So that's what this setting does. Okay.
So is it consuming the artifacts from the integration build too?
Yes, and I'll show you that in 3 seconds. So the build steps here are Octopus Deploy : create release. Octopus Deploy has a TeamCity plugin that literally creates, if I click on edit, it literally creates a runner type, a TeamCity runner type. Runner types are MS build, in unit. Well, now there's some Octopus Deploy steps that are available. I mean, I'm not writing any code here, I'm just selecting it. And so we give the Octopus Deploy server name, we give it a secret API key, we tell it which project, and again, what should we use for the release number? I want to use the same build number. I don't want to pick a new one, just use the same one. And then deployment, we're going to deploy to the test environment. We give it the name of the environment to deploy to. And show deployment process tells TeamCity to sit there and wait until, through the API, Octopus Deploy tells it that it's finished. Okay. With the production one, you'll see that we don't have that check mark, and that's why production can succeed, even though the production step requires a manual approval. All right, so I'm going to go to triggers. And triggers is wait for a successful build in integration build. So when the integration build finishes, this one is watching for it, and if it's success, it's gonna do it. And branch filter, all of them means even if I'm using GetFlow and even if I'm on a feature branch, I still want to do this. So so for a GetFlow function, you would not want your staging or production to key off of any builds that were created in a feature branch. But if we have our test environment be deployed to and the automated tests run against the test environment, then at least we run our full test suites even as we're doing a commit push on a feature branch, even before we've integrated back to develop. So failure conditions, pretty self-explanatory, if there's a failure. Dependencies. There's 2 dependencies. One is a snapshot dependency, and 2 is an artifact dependency. The snapshot dependency says everything that was true about the environment for the integration build, 1.1.139, I want to use all of those same things when I run. And so it's anything in the working copy, the environment variables, everything that was true about the environment, the process environment for the integration build, I want to, via the snapshot dependency, I want all those to be the same for me as well.
New VM better look like the old VM, otherwise I'm gonna freak out. So.
Well, there's no virtual machine here. It's really a folder full of files that it runs on. But yeah, everything true about everything. Artifact dependency is essentially telling this particular build configuration not to get code from GitHub, but to get the NuGet packages from the integration build. And so star is get every file from the integration build, and star is get every file that is in every directory. So if you only had the asterisk, it would just get the top files at the top level of the artifacts. If you have star, then it'll recursively chain down every directory and get everything. So if you literally I want everything, you have star and then you have star on the second line. Okay, and that's And that's pretty much the same thing. We don't have any parameters or whatnot. So let me go back and integration build is 1, deploy to test, promote to staging. The only difference is the octopus deploy to command. Deploy to test uses octopus deploy create release, which actually pushes a new release to octopus deploy, which is the same thing as clicking this green button that says create release. Discard changes. So if I do create release and I would say 1.1.139.1, I could create that release from the latest NuGet packages, which I can see right there, and I could create a release. I'm not going to here, but Team Cities create release is the same thing as pressing that green button on the dashboard of Octopus Deploy. Now, promote to staging, we don't need to create a new release because it's already been created and it's already been deployed to test. We just need to promote it we just need to promote an existing release to an environment, in this case, to staging. And so if I edit here, we can see that, again, we're using the deploy to test build number, and the build steps. The only difference in this one is in the promote release step, I'm promoting from test to staging, meaning I'm promoting the release from test to staging. And so if I go back and show you the configuration for promote to production, and I go to the build steps, there's only one here, and I'm promoting from staging to production. See this checkbar? This checkbox is not checked, meaning it's going to fire and forget. It's going to tell Octopus, hey, do that thing, but it's not going to wait around to see if Octopus errors out, finishes, whatnot. It's just going to say, I did it. I told Octopus to do it. Why? Because Octopus is going to sit there and wait for that manual approval button. Okay. All right. So coming back.
In unit, what does that do?
Oh, let me go back to staging. Let me cover that. Okay, good. Build steps. There's 2 build steps in this case. In unit is configured after it does the deployment to staging. It is configured to run all of the tests using the in-unit 2.6.3. Run all the tests that are in the integration test.dll in the path with a wildcard that have the in-unit category of acceptance tests. So there's the bracket categories at the top of the test fixture classes for in-unit, and you can name tests of a certain category. And so this is going to, after it's on staging, it's going to take integration test.dll and every test that's marked acceptance test, run them.
And it runs all by default, you don't specify, right?
Correct. Okay. Runs all by default, you don't specify. All right, so that's everything for Team City. Let's dive in a little bit more on Octopus Deploy. So yeah, so we have the process. Discard changes again. We have the process, and let's just go one by one. Oh yeah, client approval. You see how it says only in production. So I can say edit, and for this step, it's a client approval, and the environments that it applies to is production. If I didn't have any, it would default to all environments. Okay, so I'm going to select production. That way, the other ones, it just blazes right through. It doesn't stop at the beginning and wait for approval. It just kind of goes on. So database. If I add that column to a particular database in version 1. Or 140, then how does that work? So boilerplate stuff, Team City NuGet feed. We're gonna do configuration variables, add transform. Yeah. So there's really nothing here except get the NuGet package and deploy it to the server. And I don't even have a custom installation directory. Now, what does it mean to deploy a database upgrade? There's nothing configuration here. All the intelligence is stored in source control. Let me show you. So, because if you have a lot of configuration on this server, well, these settings that I'm showing you, they're not versioned in your Git repository. So the more you have that's not versioned, then the more trouble you'll get into, because then you'll make a source change, you'll make a configuration change to line up with it, and if that's what you're doing, then to go back in time to fix a bug, well, now you have to remember to undo the setting that you did. So you want to configure this infrastructure and leave it alone. And every change should be in source control, so that when you go forward or backwards, there's no change in configuration to the server. So in the database project, in database, we have Octopack, and I'm just going to right-click on database and say Manage NuGet Packages. And we can see that Octopack is installed. Now, Octopack is not a DLL. It is a special MS build target. And so when you actually compile with the property run Octopack, it's going to compile it, and then it's going to use the Octopus deploy process to create the NuGet package. Okay, and so the NuGet package is going to package up everything that you specify. And this is kind of small. Everything that you specify in the database.nuspec file right here. Did it? Wow, that's oh, because I'm sharing screen with Zoom, it's not doing it right. Okay, so database.nuspec file. Remember, it's the name of the project .nuspec. Okay, that's the convention. So this, there's nothing special about this. It's a regular NuGet manifest definition file for packaging. It's the Microsoft standard for specifying what should go in the NuGet package whenever it's bundled up. For this stuff right here, this is all that's necessary. In all this stuff, you can use any of the Octopus deploy variables if you need to. So if you need to poke something into it using a variable, go ahead. But only variables that are available at the time, because this is the packaging step, not the deployment step. The files, this is really what you're gonna need, because by default, it's gonna pull all the binaries in and everything that Visual Studio cares about, like DLLs and stuff. But in this case, we want SQL scripts to be bundled up because we're going to need to execute them. They're going to need to be there. So we just give it the path to the scripts. And of course, if you look at the update scripts right here, boom, there's a bunch of SQL statements. So for instance, one is create audit entry table. You know, at some time along the way, we created to create most recent expense report. Oh, here's some business intelligence additions, and so this was creating a view. You know, this view didn't exist in the database before this particular one was put in. Let's see, add total. So here's an alter table, add a total with money. I mean, just really, really simple. But every individual change to the database is in a separate SQL file in version control. And so as you go back in time to fix a bug, you might go back in time and see, oh, script number 0013, it's not there. Why? Because we went back in time before that existed. So if I run the database creation routine for the version before 0013 existed, well, it's going to give me the schema before that change happened. So at any point in time, I can recreate the SQL schema with exactly what it was at the time that code was present. Make sense?
Library in Visual Studio that runs SQL scripts, and more or less you're making a new spec file that's then going to package up to a NuGet package, and Octopack is the magic to make it run with Octopus deploy. Is that correct?
Yes. And I'm not having to create this class library. This is really just, this is an AliasQL library, and so there's really nothing that I'm doing special. Now, if there is a and there's several of these files. If there's a deploy or a post-deploy.ps1 file here, it will be packaged up, deployed, and executed. So I'm going to open this up and look right here. So this is my post-deploy file. So you take the NuGet package. The database step is going to copy the NuGet package to the destination database server. It's going to extract all the files, put it in the directory that it uses, which by default is c/octopus/applications, and it's going to copy the files there, and then it's done. Now, I have added a post-deploy PowerShell script, and there's some well-named scripts that it recognizes. This is one of them that says, okay, after you're all done with your normal stuff, look for a post-deploy.ps1 file, and if it's there, run it. So I've created a PowerShell script, and after it's there, I get some stuff out of the Octopus parameters that are essentially variables, and then I run aliasql.exe, which is my database migration tool. And whether you're using Roundhouse or DBUp or it's just a command line tool, right? And I'm running it with the database action, which in the test environment is going to be rebuild. In production, is just going to be update. And then I'm giving it the database server, the database name, and the local path to where these SQL script files are. And then it uses the regular database migration tool that we're using in our continuous integration process, and it's either rebuilding the database if it's a pre-production or non-staging environment, or it's updating the database if it's production. And that's all there is to it.
So the NuGet package is doing next to nothing, and then at the end, the post-deployment script is doing the real work. Is that correct?
Yeah,
Okay,
yeah.
all right.
I mean, we're using the new spec file to specify what files need to be there, what files need to get to the destination server, so that once they're there, once they're in a directory, this PowerShell works.
So this Octopus parameters database server, that's referencing while it's running in Octopus, the Octopus parameters.
That's right. In that long list of stuff,
Yeah.
that long list of stuff that you have access to while it's deploying, whichever, Octopus parameters is the PowerShell hook, but then the name database server, database named it. It's whichever one of those things that you need. Any, either variables that you define explicitly, or it even works. Octopus, what is it, octopus.machine.name, whatever variable that you need, you can get them. They're all there.
So how do you handle on the database side? You have a script that just added a column.
Yeah.
So when you run this again and again, isn't that column already there?
Well, yeah, but AliasQL does that for us. So any database migration tool is gonna do the right
So
thing.
you're relying on the tool to kind of help manage that.
Right, and by default,
And
But-
AliasQL,
it's an open source one that we contribute to, but we also, for one project, we use Roundhouse, which does the same thing. Some people use DBUp, which does the same thing. I mean, there's actually, at this point in time, there's actually quite a few tools that will manage database migrations by you providing a directory with sequential SQL files. And all they do is just run the SQL files in order and keep a database table in the destination database that just has a record of, has this one been run or not already? And it's a very common approach these days.
So in our environment, we don't have a tool for this. We script everything, but we script it in such a way, hey, if it exists, then don't do anything, kind of thing. So I guess using that methodology, we can still do the same script that we have and just call that PowerShell script to do a SQL CMD to.
If your process already works, then just put the command line to do it right here.
Okay. That's
Yep.
great.
Yep. Okay. All right. So let's keep going. So that's the database step. Let's keep going. And database is done. UI, I think I already showed you that. It's gonna copy the file. So actually, it's gonna copy the files. It's gonna replace tokens, and then it's going to set up a website called bootcamp / or machine name. It's going to configure the application pool on IIS. It's going to set those bindings.
And I guess like before the SQL stuff, it's there already. Obviously, it's not going to go create another website for you. Because I mean, you scroll up a little bit. You called it your application pool. That's always going to be.
That's true.
Right?
That is
So
true.
it's not going to go create another one because it can't. It's already there.
That's true. It is resilient.
So it's just kind of smart enough to do it.
Exactly. This is built into Octopus Deploy, and it is smart enough to know it's already there. But if the setting is different, it'll change the setting. Okay, and there's the bindings. Here's some more settings. Now, I'll show you something interesting because, again, that's the boilerplate stuff, but anything that might change over time or be specific, you've got this, these post deploys. So UI.newspec, in this case, I want everything in the bin folder, and I've got some configuration files besides binary, so I want everything here so that it's there. Like my in Hibernate configuration file, for instance, it's got localhost /SQL Express 2014. So this is something that connection string needs to change for every environment, right? So we have, post-deploy.ps1 here, which essentially has some XML PowerShell that knows how to deal with the in Hibernate XML namespace, and so it's updating the connection string. Now this was a specific case where we could have tokenized it, but if we tokenized the file, then it wouldn't have worked locally because it wouldn't have been a valid connection string. Make sense?
Yeah.
Whereas locally on the MVC layout, it's like, oh, I see the tokens on my website when I'm running the website locally. Big deal, right? But if you're tokenizing a connection string, well, that's not a valid connection string. It doesn't work. So we could have had a file side by side and replaced it, or we could just poke. Essentially, this is an XML poke. It's a PowerShell XML poke. All right, makes sense. And then there's another file called newrelic.config, and you see under the application node, we are essentially naming the application. octopus.environment.names -- release number. Why? Because as all of these things are changing, what about all the monitoring tools? Because in production, you have all these IT tools that need to be wired up, and New Relic is a really popular one. But if every time you deploy a new release, you have to go and muck with them manually, then what's the point? We're supposed to be automating all this. So New Relic is keys off of that. And if I just refresh this, and go back to, here's the staging environment, and it's version 139. See production, it's 138, but I think we deployed it. So let me refresh. And is it going to be 139? Did we finish deploying it? Waiting. Come on, spin it. And finish. Okay. Shouldn't be taking that long. Well, let me show you New Relic, and it might be finished.
Never type in a demo.
What's that?
It's not like all the speakers say never type in a demo.
Oh yeah, exactly. So New Relic, I refreshed it, and we can see the staging environment for 1.1.139 production. It reported, and you can see look at all these past ones that are no longer active, and so data's not reporting anymore because they're gone, right? So in this way, New Relic keys off of a particular file. So the New Relic agent is part of the image build for these servers, and all we had to do was add a new relic.config file, and that's the way this particular web works, and just put in that token, and that flows up to here so that we can look at some of the metrics and know as when the smoke tests were running, or if it's a staging environment and we have people doing some manual testing right before somebody gives the production deployment thumbs up, we can see if, as this was running, man, was the CPU spiking? Was something going on? I mean, were any of our thresholds on the environment going haywire while this is running? Because we're going to be running New Relic in production, but if it's not hooked up to any of the pre-production environments, then the monitoring and alerting capability of the environment is never being tested. So if it's not tested, it's broke. And so if it's not tested, and then in production is the first time that it runs, well, if there's an issue because we changed something in the application and we can't monitor it properly, or something changed and the performance characteristics are off and the monitors are going to start alarming, and now we've gone to production, now we've created a problem for ourselves that could have easily been avoided. And so just by whatever we're doing in production, we want to flow as much as we can all the way down, all the way upstream in the continuous deployment environment. Even as our test environments may not need to be a full web farm, maybe they're a downsized, scaled down environment, they still need to have all of the moving pieces represented so that because we don't want surprises in production. That's the principle. When we get to production, we don't want surprises. So what can we do to really squeeze out the surface area to make surprises even possible? Right? Make sense? Okay, so we've covered UI. Let's go back to the process. Now we have tests. And if I go through here, the integration tests are going to copy, and there's nothing here. Okay, so the integration tests get copied, and we go to here. And we have a post deploy that runs some smoke tests, and it's because it's using the database, it uses the same XML poke for that in Hibernate file that I talked about. So this is the same thing. And then at the bottom, we are taking our in-unit console, and we are using a built-in test with a category of data loader, which at the end of everything puts into, is an automated fashion to put into the database the baseline data that needs to be in the database for the application to even do anything. So like if your application has a drop down for states in the United States, you might have 50 records in there. And if there's no data in that database, then the drop down doesn't work and things fail and all that stuff. So whatever baseline data is necessary, that is responsible for when I get to staging. Is this staging? Yeah. When I get to staging, guess what? No, this is a sample app, so I don't have a password, but I've got some users that I can use to log in. That's how the records got pushed into that database. Okay. So whatever mechanism you have so that you don't end up with, well, there's absolutely nothing in this pre-production database, so I really can't do anything. I really can't run any tests. It's just, so whatever steps as you go through and say, what do I need to do? What is a deployment, and what are all the steps necessary to get this environment to the point where it's useful, and you have hooks every step of the way to be able to run the commands to make that possible. So in this case, I'm using the post-deploy.ps1 hook. It's just going to run the PowerShell file. It doesn't care what's in it, and this is the command that I happen to put in it in order to facilitate that. All right, so that is the test step. If we come back to web smoke test, and this runs in every environment. If I come to this doesn't use a NuGet package at all. This just says, in this step, I want to run a PowerShell script. Okay, so the PowerShell script, if I maximize this, it's going to get the machine name, and it's going to invoke the web request. That's just a PowerShell command, and it's going to look at the page, and if the page does not have the text expense report system, it's going to throw an exception. Web smoke test failed.
The only reason we use NuGet at the moment goes to dragging flat files is that we have to do single scripts. So the distinction between that and this.
So every one of these NuGet packages has a post-deploy.ps1, and we can put any PowerShell we want in it.
Right. You could also just do like a web smoke test and skip NuGet altogether, right? And just run a PowerShell script. So why?
Yes, we can.
So the reason you use NuGet to begin with was because you drug in their SQL scripts. Is that correct?
Yes, and by using NuGet, it pulls what we have in source control and uses that. By using a PowerShell step, we need to make sure that this script is not volatile. This script should not change. If it does need to change and be versioned, well, then we need to just put it in our Visual Studio solution, pull it in via a NuGet package, and then execute it so that it's versioned. If we're going to put something in Octopus Deploy as a PowerShell script, then we need to make sure it's something that we don't need to version. Okay? So as we see this, and this is, I am using it for an example, and you could make an argument, well, wait a minute, we really should do it, but I'm showcasing an Octopus Deploy capability, okay? So if we go to, if it navigates here and finds this text, great. If this blows up with a yellow screen of death because something went wrong, then it's obviously not going to see the text, and so just that smoke test for the deployment is, yeah, I did all these steps, but the website's not starting, and I'm not getting to this page, and this page is not doing what it's supposed to do, so the deployment is going to fail because we can't find it. Or it's going to say web smoke test passed. Further, if it says web smoke test passed, then we're going to use a little more PowerShell, and we're actually going to create an instance of Internet Explorer within the PowerShell process. We're going to navigate to the logout URL to make sure it's a fresh session, and then we're going to navigate to the base URI. We're going to make sure that Internet Explorer is not visible, and then we're going to pull up the web page. We're going to find. We know on the login page there's only one button, so we're going to find that button. We're going to click it, and with these get elements by tag name, all of them are piping through. And when you pipe through, everything has to be enumerable. So even though we know there's only one, to pipe through, you still have to do a for each just because that's the way it works. And then we're going to get all of the anchor tags, and we're just going to loop through and click on them all. So it's basically like a little stupid little web crawler spider. We're just going to log in. Hey, I have a page. Let me just harvest all of the URLs from all the anchor tags that I see. Let me put them in a list, and let me just rip through and hit them all. And if any of them throw an error, well, okay, I fail. Something's wrong. I don't know what. So we have all those anchor tags, and in this application, we happen to know that there is a URL to our corporate website, and so we don't want to navigate just to the open internet. We only want to navigate within the application in our smoke test. We don't want to end up, and so we invoke a web request for whatever that URL is going to be, and then we log out again, and then we tell Internet Explorer to quit. That's very important. If you don't tell Internet Explorer to quit, then you have an invisible application just sitting there on the server, and as it's cranking, at some point, you can't create some number of new instances of an existing COM component. If anybody remembers, from 15 or 20 years ago, there's a practical limit when creating COM components, and your process will just go into zombie mode, and nothing will happen. It won't throw an error. It will just stop doing stuff.
They'll be just listed in the processes. Can't you go and kill them in the processes?
Well, while that is true, this Octopus server is just running on the background, and no one's really attending to it.
Oh.
So if you leave it, unattended, just go about your way. For some reason, it's like, hey, deployments aren't happening anymore. What's going on? And then you have to do some manual intervention. So we want to make sure that we clean it up and quit that COM component. Otherwise, that'll happen.
So you're saying it will have to be some admin on that cloud to go in and manually
to
kill
get
those programs.
exactly. So anytime you're running, you want to. That's the thing with COM. COM does not automatically clean itself up like that netcode does, or like PowerShell does.
When you say write host, where do you see all that logging? I guess.
Good.
Is that in Team City?
Yes. Let's go to. No, it's not in Team City. Actually, let's. I'm trying to remember how much of the logs it actually funnels back into Team City. Yes, all of it's an Octopus, and it funnels all of it back to Team City. So web smoke tests in Team City, you can see all that stuff.
Does PowerShell have something equivalent to like try catch find when you're using statements in Sharp, so you're destroying IE?
Well,
Okay.
but there's not going to be any exception. So there's nothing that would. I mean, and finally, just doing IE.quit, that's what you would put. But yeah, it does have a try catch finally. Let's see. No, I don't have it here, but yeah, there is a try catch finally. So yeah, so that's all.
Once you've got all this set up, like you got Octopus set up and deploying your stuff, you're really never in Octopus. Probably, right? You're
in your source code.
Now that all your stuff gets written over to
you set up the infrastructure once, and you're just in your source code. Because that is where you should version everything. Mm-hmm. You shouldn't be changing. It's like now it's set up and running. Unless you add a second website, add a Windows service, or unless you add a new system component where you have a new shape of your system. Unless you're doing that, you shouldn't have to touch your build server. You shouldn't have to touch your deployment server. It's just running. Everything you're changing is in your Git repository. So, in conclusion, feel free to go to this Git repository, and I mean, you'll have to set up your own Team City server. You'll have to set up your own Octopus deploy server, but this application here, it has all the hooks. It has all. I mean, you can just use it as a starting point. It's a tiny little stupid expense report, sample. It doesn't really. It's got 3 screens to it total. So it's just a shell of an application, really.
But I can build what you build.
Yeah, absolutely. Just pull down the code, use it as you see fit.
Do I need that alias SQL?
It's in the source. It's a tool. I mean,
okay.
Yeah, I mean, it's there. Yeah, I mean, you're going to have to install TeamCity, you're going to have to install Octopus Deploy, and you're going to have to install SQL Server Express locally and you give it an instance name of SQL Express 2014. We just tag, and that, I mean, those are the only environmental dependencies
Or changes
just to use this code. Yeah, sure. And Visual Studio 2015. So, all right, that's that. Took about an hour and 20 minutes, and I didn't really go into the C# code. This is just the sort of the configuration management that sort of is around the code, whatever features, whatever architecture you chose, you know. So yeah, feel free use this code, and an article on this is going to be in the March issue of Code Magazine, and actually I prepped this for writing that article, and so that'll be published pretty soon. And that's that.
Is there documentation for, like, if I never configured Octopus before,